Hello everybody. So this is a video for you on the ideas of and the ideas of or in probability, because they mean slightly different things than they do in the English language. Okay, so we're going to talk about what those things mean, and we're going to do some practice problems, and I'm going to show you some of the symbols and things that go with that. Okay, so the first thing that we're going to do here actually is take a look at this lovely list of people right here. Okay, so there are 12 people total. Oops, I'm still on my rectangle. Hold on one second, y'all. I gotta clear this off. Let's try that one more time. Okay, so I'm looking here. Let me switch back to my pen here. Okay, so I have 12 people total. Okay, obviously their genders are listed here. Obviously gender is a spectrum, but these people were asked to choose male or female. Okay, and then their ages are listed as well. Okay, so remember, if we just think about basic probability, right? Probability is the number of successes divided by the total. Right? Okay, so here, the first probability here is I want to know what's the probability that a contestant is named Casey James. Well, there's only one of those people, right? So that probability would be 1 out of 12. Okay, now the next question here is the probability that a contestant is female. So let's go through and look at and make a list here, count how many of these people on my list are female. So I have here 1, 2, 3, 4, 5, 6. Okay, so that would mean my probability would be 6 out of 12, which you could reduce if you want to, because there is a common factor here between 6 and 12. Greatest common factor is 6, so 6 divided by 6 is 1. 12 divided by 6 is 2, so that could be reduced. Okay, all right, the next question is asking me, okay, what's the probability that the contestant is under 21? So I want to look for all of the people that are under 21. So here's a person under 21, here's a person under 21, here's a person under 21, and here's a person under 21. So there's 4 of those people. So that probability is 4 out of 12, which again, you can reduce if you want to. There is a greatest common factor here. 4 and 12, their greatest common factor is 4. So 4 divided by 4 is 1, and 12 divided by 4 is 3. Okay, so the last 2 things we have to figure out here are what's the probability that I pick a person who is both female and under 21, and then what's the probability that a contestant is female or under 21. Okay, so in probability, and means the same thing as it does in the English language. And means that whichever person you pick has to fall into both of those categories. All right, so take a second, think for yourself, how many of those people that we have listed fall into both of those categories? So take 5 seconds, figure it out. Okay, so if I want people that fit into both of those categories, I need both of these things to be underlined, right? So this person fits in both of those categories, and this person fits in both of those categories. So my probability here would be 2 out of 12, which again can be reduced. Greatest common factor between 2 and 12 is 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Okay, so that's an and probability. Okay, now an or probability means something a little bit different than it does in the English language. Okay, in the English language, or means one or the other, like it can't be both. In probability, Okay, in probability, a person could fall in this first category, this second category, or both, right? So the person that you pull or that you select just has to be in at least one of those categories, but they could be in both. Okay, so I want female or under 21. So that means I need to have at least underlined one of these two things, like in the parentheses next to their name. So this person fits the bill. This person fits both, right? This person only fits female. This one only fits female. This person fits both. And this person only fits the under 21. Okay, so that's 8 people total. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 12. Okay, and that reduces to the greatest common factor between 8 and 12 is 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Okay, so there's a couple of things that I'm hoping that you noticed here, okay, about the difference between the and probabilities and the or probabilities. The and probabilities are very exclusive, and it's always going to be less than the two individual ones, right? So like each of these individual probabilities, 6 out of 12 and 4 out of 12, the and probability is smaller, right? But the or probability is actually larger than both of them individually. Okay, right, so those are some good things to notice, right? Okay, so I want to tell you a little bit here about my symbols here, right? So what these probabilities names are, what their symbols are, and how we would actually write them. So you can see it there on the left side of your screen, okay? But our fancy geometry term for and, okay, is the word intersection. Right, which kind of makes sense, right? An intersection is where like two streets come together. So an intersection in probability is like where two categories come together, right? It's like the overlap between them, okay? In probability, we symbolize the word and using this upside down U right here, okay? The way that I usually remember that is that it almost looks like an A, just without the line in the middle. See that? If you like draw the line through the middle, it kind of looks like a capital A, right? So that's how I remember it, at least. Okay. Now, if I wanted to write this as an equation, right, or like in probability notation, it would look like this. So if you see something like this, this means the probability that event A and event B work together. Right? And remember, with probability notation, you have to put a little p in front, and then the actual little equation goes in parentheses, right? So this literally translates in English to the probability that A and B happen together, okay? All right, so for or, okay, our fancy geometry name for that is it's called a union. Okay, so a union. All right, the symbol for a union is just a regular U. Okay, so pretty easy to remember. U, union. Okay, so the way I would write this as an equation would be like this: A union B. So that regular sized, that U right there, that U that's facing the right way, literally translates to the word or. It literally means or. So this equation here, if I wanted to translate it into plain English, would be the probability that event A happens or event B happens. And remember, that could mean that those two events happen together as well, right? All right, so with that, we're actually going to do the number 2 activity kind of in class together. So give me a second to rearrange my screen a little bit, and I want to show you how these two ideas work together in something called a two-way table, right? So I'm going to pause real quick. I'll see you in just a second. Alrighty, folks. So let's talk a little bit about two-way tables. Okay, so two-way tables are a way for us to organize data into two different categories. So there's always one category on the top and one category on the side. So in this example, we're talking about different types of like tablets, you know, like iPads. So the tablet type, right, is one category, and the amount of storage that the tablet has is the other category. Okay, so first thing that you should always do when you're doing a two-way table is to fill in the totals for each row and each column. Okay, it'll make the rest of the problem a lot easier if they don't fill that in for you already. Okay, so the way that you do that, so say for example, I wanted to find this, right, the total 16 gigs, I would add those two values together, so 75 and 95, right, and that is 170. Okay. All right, and then if I wanted to do the same thing for the next row, I would add these two together, the 42 and the 63, so that's 105. Okay, I can do the same thing for the columns. Okay, so let's say, for example, I wanted to find the total of this column right here. Okay, I would add 95 and 63, and that gives me 158. Okay, I can do the exact same thing for the classic tablets. So 75 plus 42 is 117. Okay, now the total, so this guy right here, okay, you can get that lots of different ways. You could add all of these individual numbers that they give you, or you could add the row totals right here, the 170 and the 105, or you could add the column totals, the 117 and the 158. You're going to get the same answer either way. So if I add these up, the easiest one, it looks like to me, is 170 plus 105, and I get 275. Okay, so that's going to be very useful for me when I'm going through and solving the rest of these problems. Okay, so let's look first at just a basic one here. Okay, and then I'll talk to you about how we can figure out and scenarios and or scenarios in a two-way table. Okay, so this first question right here says, if a tablet is chosen at random, so if we just pick one of these at random, what's the probability that it has 32 gigabytes? Okay, so if I wanted to write that in probability notation, I would write it this way: the probability of, and I'm just going to write what I'm trying to find the probability of, which is, I want to know how likely is it that I pull a tablet that has 32 gigs? Well, remember, basic probability is just how many successes you have in that category, like how many 32 gig tablets I have, divided by the total in the group. So there's 105. Okay, there's 105 32 gigabyte tablets. Okay, and then there's 275 total. So that would be my fraction, right? And honestly, that's not really one that I want to reduce. Like, I don't really want to have to do that in my head, like to simplify it to a fraction. The question also says to round to the nearest thousandth. Oh my goodness, I can't speak English today. So what you would do in your calculator is you would do 105 divided by 275, and it's going to give you a decimal. So I got this decimal, 0.382. Okay. All right, so let's look at part C, because this is going to be an and probability here. So this says, if a tablet is chosen at random, what's the probability to the nearest thousandth that it is a tablet mini with 16 gigs? So meaning it's a tablet mini that also has 16 gigs. Okay, so if you look on the left side of your screen, you'll see your strategy here for an and scenario, right? So what I'm trying to find here is the probability that I get a mini and that mini has 16 gigs in it. Okay, so remember the little upside down U means and. Okay, so your strategy here would be to look at where the two categories intersect, which I actually already have drawn for you right here up in the actual table. So 16 gigs is this purple circle right here, okay, and then mini is this pink circle. So where the two categories intersect is right here. So that's the numerator of your fraction. So it would be 95 divided by the total, which is 275. Okay, and again, once I get there, I'm just going to plug that into my calculator and figure out what that is. So that's 0.345 when I plug that into my calculator. Okay. All right, let's look at these, the last three here. So I want to know for part D, what's the probability that I get something that is not a mini? Okay, so if I wanted to write that in probability notation, I would write the probability that I have a mini, but not. Right, so remember, that's what that little C means. It means complement, it means not. Okay, well, I need to think to myself, okay, if it's not a mini tablet, what kind of tablet is it? Well, there's only two categories. You can either get a mini or a classic. So if it's not a mini, it has to be a classic, right? So there's 117 classics, right here, divided by the total in my table, 275. Okay, so if I plug that into my calculator, I get 0.425. Okay, now, shocker, let's take a look at the next one. The next one is asking us basically the same question. It says, what's the probability that I get a classic, right? So I would write that in probability notation this way. Okay, what's the probability that I get a classic tablet? Well, it's exactly the same as the last probability we calculated. There's 117 classics out of 275 total. Okay, so that decimal there is the same. That decimal, that fraction is the same. Okay, right? So sometimes you'll see probabilities written as like not probabilities, which is what this one is right here. Or you may see them written as like direct probabilities, okay? I could have figured out what this complement probability was by doing 1 minus the probability that I do get a mini, because remember, that's the complement rule. So I could do it that way, but honestly, when you have a two-way table, it's a little bit easier to just say, well, there's only one other option, right? So okay, let's take a look at the last one here. So in this one, I want to know what's the probability that I get a classic or a mini. Okay, so remember, or in probability means one or the other or both. Now here in this problem, it's not possible for me to get both a classic and a mini at the same time. Like I can't pull just one tablet and have it be both a classic tablet and a mini tablet, right? Because they're separate. Those two categories don't overlap, okay? So the way that we usually figure out how, like what that probability is you would add those two categories together, right? But classic and mini are my only options, right? So if I wanted to find the probability that I get a classic or that I get a mini tablet, okay, those are my only two types of tablets. Those are my only two options, right? So that would end up being 1 or like 100%. Right? Because all of my tablets are either a classic or a mini, one or the other, which is like 1 or 100%. Okay? All right. So we've got, right, and you can kind of see the answers there. So those two events right there, and we're going to talk about this in a little bit more detail in another video, but those two events right there, classic and mini, are called mutually exclusive, right? We have this very fancy term for it that just means that those two categories never overlap, right? That they don't have any intersection, right? So like these two categories, the 16 and the mini, those are not mutually exclusive. They're overlapping, right? Because they have 95 tablets that fit in both categories, right? The classic category and the mini category have no tablets in common. They don't overlap. So that's why we call them mutually exclusive. All right. Okay, so we've got one more problem here. Okay, so what I would love for you all to do actually, okay, is try this one out on your own. So go ahead and pause the video and try this one out on your own. What you have to do is fill in the rest of the totals here, okay? And then you're finding these 5 probabilities right here, okay? Keep in mind that you have to write both of these, okay? They're not both of them. You have to try to write all of them with the probability notation like I did up here, okay? You should, at the very least, be able to do the first 4. The 5th one might be a little bit tricky, so check back with me once you're done with these problems to check your answers. All right, folks, so I did the first 4 on here for you, okay, and then I'm actually going to work the last one out for you by hand, okay, live here. So you should have filled in all of your totals first. So your total number of BC tests taken was 62, and then the total in each score category went 67 in the 5 category, 42 in the 4 category, 47 in the 3 category, 27 in the 2 category, and then 73 in the 1 category. And then your total in the table was 256. Okay, so the first 3 were hopefully pretty simple, right? So first one is, what's the probability that I pull a student at random who took the BC calculus exam? So there's 62 kids that took the BC exam and 256 kids total. So you just divide those in your calculator and you get 0.242, okay? For the second one, I wanted to find what's the probability that you pull someone that gets a 5 on the test. No matter which test they took, what's the probability that they got a 5? Okay, so there were 67 kids total that got a 5 on their respective exams. So 67 divided by 256 is 0.262. Now, for the third one, you could have done this a couple of different ways, right? Because it was asking you what's the probability that someone did not get a 5. So there's 2 ways you could do this. You could say, well, if they didn't get a 5, that means they had to have gotten a 4, a 3, a 2, or a 1. So you could have added all of those up together, right? That would be one way, okay? Right, so like you would have added these 4 right here. Right? And if you add all those up, you do get 189, okay? But what I think is a little bit easier, because there's so many categories, is to say to myself, well, since I already calculated the probability that someone got a 5, I can just do 1 minus the probability that somebody got a 5, because that will give me the probability that someone did not get a 5, right? Because there's really only 2 options here. You either get a 5 or you don't get a 5, right? That's the whole idea of a complement, right? That's what that little C means right here, right? Remember, it literally means not, okay? So when you have a bunch of like entries in your individual categories, like a lot of possible options, it's sometimes easier to do the subtraction method than it is to add all of the other things up together. So that's what I did. That's what you're seeing on the screen right there, okay? So I did 1 minus the probability that someone did get a 5, because I already calculated that in the second one, right? So 1, if you wanted to write 1 or like 100% as a fraction, it's the total divided by itself. So 256 divided by 256. And then I'm subtracting the fraction that I got in the second one there. So 67 over 256. And notice that I get the same number. See, I get 189 as my number of successes, no matter which method you use. So just pick the one that makes the most sense to you, okay? So my final answer there is 189 out of 256, which is 0.738. All right, let's take a look at number 4. Okay, so number 4 is asking us to find what's the probability that I pick a student who both took the BC exam and got a 5. So what you're seeing kind of outlined and circled in green in this two-way table is those two categories, right? So because whenever I'm trying to find an and probability, the goal is to see where do those two categories overlap, okay? So, okay, right? So I have my 5s here and my BC category here. So where they overlap is outlined and circled in pink right there. Okay, so my total in both of those categories together is 28. So my probability is 28 out of 256, which is, when you plug it into a calculator, 0.109. All right. Now the last one is a little bit tricky because you may have gotten part of it, but you may have forgotten like a step here. Okay. So here I'm trying to find the probability that someone took the BC exam or they got a 5, right? So in the last one, what we did to figure that out is we just added the totals in the two individual categories, right? And we were able to do that because they were mutually exclusive, right? But here's the issue, right? If I just add the totals in both of those categories. So let's say I did that, right? So for BC, my total was 62 out of 256, okay? And then I say plus, I want to add, because remember, they can be in one or the other, right? Or both, right? So I can add the totals then in both of the categories. So 62 out of 256 for BC, and then 67 out of 256 for 5s. But the problem here is that you have some people that got counted twice, and it's these 28 people that fit in both categories because they're counted here in this 62, and they're also counted here in this 67. So what that means is you have to subtract one of them out because otherwise those people will get counted twice, and then my probability is going to be incorrect. Okay, so I would add 62 and 67 and then subtract 28 from that. And when I do, I get that that is 101 out of 256. Okay, and if I plug that into my calculator, I get 0.395. All right. So we're going to get into a little bit more detail about this idea, like this idea of subtracting what two categories have in common in a future video. All right. But whatever video you watch next, I'll see you in the next one. That's it for this one. Bye, everybody.